All right, so in the unit circle, in how the unit circle is developed, basically you need to remember that the radius is 1. So no matter what point on the unit circle, it always has a radius of 1. Therefore, the circumference, which is 2 pi r, would be 2 pi times 1, which would be 2 pi. So when we talk about radian measures and so forth, 0 degrees would be equivalent to 0 radians. When I go up to 90 degrees, notice we just said that 2 pi was the entire circumference. So 2 pi all the way around. Well, if I only go halfway around, then that's where we get the 1 pi. And then half of that would be pi half. And then this would obviously down here be 3 pi halves. So that's where the general pi half, pi, and 3 pi halves comes from. We've already talked about the 0, 90 degrees, 180, and 270 before. All right, also on the unit circle test, do not forget your points. A lot of you will forget the points for the easy ones, the 0, the 90, the 180, and the 270. So make sure you might want to go ahead and do those points first, just so you don't leave them off and get points off for this grade. All right, the next ones we're going to do is we're going to go ahead and take and cut these in half. If I take halfway between 0 degrees and 90 degrees, that's the 45 degrees. See, this is a reference of 45. So if I took 180 minus 45, that's 135. 180 plus 45, that's 225. And 360 minus 45 would be 315. So that's each of the 45-degree angles. Now remember, this is a unit circle where the radius is 1. So as we take a look at the 45, 45 right triangle, we have a length here of 1, 1, and the hypotenuse is square root of 2. But see, if I want to make that be a length of 1 for the hypotenuse instead, I would divide every one of those sides by the square root of 2. So it would look something like this. Now I have the hypotenuse of 1, and each leg is 1 over radical 2, which simplifies to radical 2 over 2. That is where this first point comes from. Here in a minute, we'll talk about that point. Right now we're going to go to the radian measure. So when we're going from 0 to pi half, halfway would be pi fourths. If I ask myself, how many pi fourths does it take to get to 135 degrees? See, 45 divides into this 3 times. So that would be 3 times pi fourths. This would be 3 pi fourths. Then I would ask myself, how many times would 45 divide into 225? So if you actually do the division, that would be 5 of them. So therefore, 5 times pi fourths is how I could get this one. Again, how many times does 45 divide into 315? So you could use a basic calculator, do 315 divided by 45, and you're going to find that goes into it 7 times. So that would be 7 pi fourths. Now, a minute ago, we just did that 45, 45 right triangle. When we did the 45, 45 right triangle, we said the leg was 1 over radical 2, and this leg was 1 over radical 2. See, right here would be like you have a 45, 45 right triangle right there. See, this leg is that radical 2 over 2, and this length is radical 2 over 2, and that's where this point comes from. Now, after that, everything is just symmetric. So this is symmetric about the y-axis. When it's symmetric with the y-axis, you do negative x for x. This point to this point is symmetric about the x-axis. When something's symmetric with the x-axis, you take negative y for y. From this point over to this one, it's symmetric with the y-axis, so therefore I take the opposite of x for x, and that's how I get all the points in red. All right, now I'm going to use the 30-degree reference angle. So I'm going to take the 30-degree reference angle. So this one would be 30 degrees, 180 minus 30, 180 plus 30, 360 minus 30. All right, we're going to take those into radian measures at this time. So remember the radian measure, pi radians is 180 degrees. So I would have to think about that for a minute. 180 divided by what would give me 30 degrees? Well, see, that'd be 180 divided by 6 is equal to 30 degrees. So this is equivalent to pi over 6. Now I would ask myself, how many times does 30 divide into 150? See, 3 times 5 is 15. Therefore, this would be times 5. So 5 pi 6 right there. Again, I'm going to ask myself, 30 times what is 210? I can ignore the zeros and take 3 times what's 21. That'd be 3 times 7. So pi 6 times 7. All right, 30 degrees times what is 330? Again, ignore the zeros. 3 times 11 is 33. So times that by 11, and there's the radian measure. Now we take a look at our 30-60 right triangle. Notice that hypotenuse has a length of 2. But see, this was a unit circle. I want that hypotenuse to have a length of 1. To have a length of 1, we would have to divide every single side by 2. So again, I'm going to divide every side by 2. When I divide them by 2, I now have the length on the right is 1/2. The length on the bottom, radical 3 over 2. And now I have a hypotenuse of 1. See, notice right here, this would be my 30-60 right triangle right there, where this is the 30-degree angle. If that's the 30-degree angle, this length right here was radical 3 over 2, and this length was the 1/2. Notice the x length, that's the horizontal length, then the vertical length was the y length, which was 1/2. Now, when we have something symmetric with the y-axis, we take negative x for x, which you guys have a flashcard for in your Quizlet. When you reflect something over the x-axis, you take negative y for y. So notice that y changed. I'm reflecting back over the x-axis, now back over the y-axis, now I take negative x for x, so therefore that becomes back to a positive. All right, now I'm going to take my angles all up in blue, and this time I'm going to use a 60-degree reference angle. So 60-degree reference angle from 0 to blue is going to be 60. 180 minus 60 is going to be the 120. 180 plus the 60 is 240. And 360 minus 60 is going to be 300 degrees. Convert those to radians as well. Remember, pi was 180 degrees. So I need 60 degrees. What would this have to be divided by to make it into 180 degrees? See, 180 divided by 3 would be 60 degrees. So I need pi divided by 3. This is pi thirds. Then again, I'm going to look at 60 times what's 120. So 6 times 2 is 12. So take that times 2, and that'd be 2 pi thirds. Again, I'm looking at the 60 to the 240. See, 60 times what's 240? Or ignore the zeros, 6 times what's 24? That'd be 4. So this is 4 pi thirds. Again, 60 to 300. What does it multiply 60 by to get 300? Or ignore the zeros, 6 times what's 30? That would be 5. So this would be times 5 as well, 5 pi thirds. So that's the radian measures. Now for the angle measure. We had just done that 30-60 right triangle, where we had the radical 3 over 2, the 1/2, and the 1. If I was to turn my triangle, if I was to, do your rotations and so forth, basically now this is the 60-degree angle here, come up, and then I have a 30-degree angle. See, these x's and y's right here switch. This is the short length. This is now the long length. See, the short length is opposite 30. The long length is opposite the 60-degree angle, which from the here to the blue is 60 degrees. So this x and y flip from 30 degrees. Now I'm going to reflect it over the y-axis. Reflecting over the y, I get negative x for x. Reflect this over the x-axis, I'm going to get negative y for y. And then reflect over the y-axis again. When you reflect over the y, you put negative x for x, so I'm going to switch that one. And that's how you complete your unit circle for your unit circle test. Hopefully this helped you guys out. Have a great day.